Hey, what's going on, my ASVAB party people? Anderson here, your ASVAB coach, and I want to thank you for watching this video. It's a free recording. That way you can raise your score, get the score you want, and the military job you deserve. All I ask is that you like, comment, and subscribe to this channel. That way we can keep putting out great content for you on a week-to-week basis. And if you like what you see in this class, feel free to check out the full website. That way you can get all of the resources that you need to pass. At the end of the day, it's about getting the score you want and the military job you deserve. So if you want to join the classes or use other great resources, those links are going to be in the video description below. Get to it and let's ace the ASVAB. That'll make a lot of sense. So with that said, gang, let's go ahead and just start off by talking about these key words when it comes to solving equations. So if you want to take a screenshot of this, please do, because it's very obvious that this is a lot, right? So we're just going to go through some of these words here, and I want you to just understand it, like feel it out and really make that connection as to why it makes sense. Because remember, like we're all starting from different places, but even if you're already, quote, good at solving equations, we can always get better. And if you feel like you have no idea what's going on at all, continue trying and ask yourself, well, what do I understand? Where can I go from here, right? You don't want to just be like, oh man, I don't know what's going on, bye, peace. Like those are the people that are going to fail. Those are the people that say, oh man, I could have passed. Come on, don't be that person. Let's go ahead and pay attention. Let's lock in here. So let's first start off with addition. So let's talk about some words that we can hear in common word problems that really signal that we're adding. Some, we've heard that before, right? Plus, total of, together, added to. These are like the main ones that you're going to see. Now, some of these are still common words, but these are words that you may not automatically know that it means adding. Combined. Combined means add. More than. Older than. So in word problems where you're dealing with age, give me a yes or no in the chat box. Have you ever dealt with a word problem that talked about someone being older than or younger than somebody else? And maybe you didn't know what to do. Look at that chat box blowing up. Exactly. We've all been there, right? We've all been there. And so we need to understand that when we're talking about adding and subtracting in word problems, they're not going to specifically, explicitly say like things about adding and subtracting. Things like older than, less than, or younger than, those are words. Those words really account for adding and subtracting. Farther than, when it comes to distance, like if we're talking about how many miles people are going. Farther than. Consecutive. Consecutive. Everybody, what does consecutive mean? How much are you adding if you say consecutive? Who knows? And I blocked off the mic for this free session because there's a lot of people in here, so I want to make sure that everything's good. So consecutive means what? Who knows? So if I say, hey, I got two consecutive numbers, that's right, one after the other, one after the other, one after the other. So adding one essentially. If we say consecutive, you're essentially saying adding one. Another one, greater than and increased by. And so these are more common, but I want to make sure we go through all of them. I'm telling you, it's very important. Looking at subtraction, left, less, less than. There's a very big difference between less and less than. For example, if I say, what is, 2 less than X? Yes or no, did you know that 2 less than X? Let me write that out. 2 less than X. Which one does it mean, everybody? Does it mean 2 minus X or X minus 2? Which one does it mean? Which one does it mean? Who knows? John's like, wait, hold up. Yeah, it's going to be that second one. It's going to be that second one. When you say 2 less than this number, think about a real world situation, guys. Think about a real world situation. Let's go ahead and say that I got $10 in my pocket. If I got $10 in my pocket and I say, oh, let's go ahead and take a look at, let's say, Roxanne, I'm going to call you out. So Roxanne says, oh, I got, 2 less than $10. I got 2 less than that. That would mean 8, right? And so you would take the 10 minus the 2. When you say a number less than another number, you're doing that second number minus the first. That's a very, very, very particular little rule that a lot of people don't know. But yeah, 2 less than X means X minus 2. You got to make sure I call that out. Yeah, it is a little tricky. I absolutely agree. But we got to make sure we look out for those little things. That way, we don't have to get nervous. And so next, difference. We know that. We should know that, right? At least at some point we've heard that. Fewer than. smaller than, and now we're getting into those other situations. Younger than, diminished by, subtracted from, decreased by. These are all words for subtraction. Up next, multiplication. And I want to look at multiplication and division at the same time. Notice how multiplication, if you just have the word of, that means multiply. If we see out of, that means divide. Has anybody ever gotten confused by that before? Between the difference between of and out of. And there it is. And that's okay. And again, we're here to be honest. We're not here to try to protect our egos. We're just looking at these situations and saying, hey, what are these common mistakes that we want to look out for? That way we can be good moving forward. But twice, triple, that means times 2, times 3. Each is a huge one that we're going to be using today as well. Times, product of, multiplied by, all multiplication. Make sure to write these down or have the screenshot ready to go. And lastly, for division, in, per, split, out of, ratio, average, percent, quotient, oh, that's the most obvious one, equal pieces. These are all signals of division. These are all signals of division. All right, gang? And so hopefully we've had enough time to write this down. If you didn't, take a screenshot real quick, because we're going to go to this next screen here. I'm going to ask y'all the one thing that we haven't talked about yet. We've talked about the operations, but we haven't talked about equals. So let's go ahead and talk about that real quick. Let's go ahead and shout ourselves out here. So who knows what are some words in word problems that mean equals besides equal itself? So let's go ahead and write that out. You know, equals is definitely one of them. I see 3 is. All right, cool. Is. What's another one? There's a few more. Nope. Total means in all, everything together. Not quite. Not specifically. Are could be part of it. Yeah. All together. Same as. Yes, I'll take that. Same as for sure. Same as. Combined would mean adding. There's some more here. There's some more. Don't just think about present tense. Think about past tense, future tense. What can we think of there? What can we think of there? Ooh, equivalent. I love that. John, Mario, nice. They usually say equivalent to. Yep, absolutely. Comparable, uniform, result right there. Results. How about was or will be? Those are 2 more right there. Was and will be. Amounting to. Ooh, Rakenya. Yes. Yes. Amounting to. So basically this is equal to this, or this amounts to that. Yep. Absolutely. Absolutely. Dilson, fusion, not quite, bro. That's good though. That's good. Not quite. Identical to. Yeah, they typically won't say identical because identical typically talks about objects, not numbers. But that's a good one though. Sold for. There's another one, Shane. Right on, boss. Sold for. Final price. Now we're talking. There we go. Final price. And so we can stop right there. These are all really good ones. These are all very, very, very good ones. And so I just want to make sure that you guys understand that it's not just about seeing the word is or equal specifically. There are a ton of other words. There's a ton. And so we got to make sure that we understand these here and then practice with them. That way we can continue identifying these things. And so with that said, we're going to start ourselves off here. So this is a question that I posted over in the Facebook group. So if you're in the Facebook group, boom, we're going to go ahead and go over this one right now. If you're not in the Facebook group, I'll go ahead and give you guys the link to the Facebook group later on in the session. That way you can join and make sure you're keeping up with all the updates, all of the samples I put out, and all that jazz. So with that said, before we begin this, everybody, what's the first step in solving any word problem? And I'm going to let the mic go. I'm going to let the mic go. Go ahead. Use the mic if you'd like to.
Read the question.
Read the question.
I always read the question.
Yep.
All right, cool. So my new people here today, you probably know who my group tutoring past folks are. That's them right there. So when it comes to solving word problems, every single time, you got to make sure you start by reading the question. The fact of the matter is, there's a ton of information. Why would you go and start surfing through all of the information before you know why you're actually going through that information? It's like reading a book without reading the title first. Like, it's going to be very boring or very hard to kind of get into if you don't know what kind of a story you're going into, right? And so you want to make sure you understand completely before you start the problem, what is it that I'm trying to find? That's it. Like, what do I want to find? And so that's why we go straight to the question. First step, straight to the question right here. And so this first part right here, this whole if thing, not exactly necessary. Not exactly necessary to look at. If she spent this much money, yeah, that's good information. That's going to be important. But the question itself is right here. The who, what, when, where, how many, which of the following, those question action words, that's where you want to start. So remember that. Start with the question itself. That way you know what's going on. How many shirts did she purchase? That's it. That's it right there. So we want the number of shirts purchased. Number of shirts equals blank. Like, honestly, this is how you want to start. Because again, at the end of the day, if you are sitting here starting off by reading all of this information, chances are about 2 sentences or 3 sentences in, you're going to be like, what did I read again? Oh man, I saw a decimal. I'm really nervous. Oh man, I don't like that fraction. Like, you're going to start thinking about things that really don't matter. And I'm sure a lot of you guys have been there before. Start with the question. And so there it is. We're looking for how many shirts we purchased. And so what's coming next? Well, what's coming next after the question? So let me go ahead and just write right here. Step 1, question. Now it's going to be keywords. We're going to find out the keywords here. So what we want here again is how many shirts, right? Right there. So what I'm going to do is I'm going to go into the problem, and all I care about is any information that has to do with shirts. That's it. That's all I care about. So watch this. Kelly went shopping at the mall. She bought some shirts for $13 a piece. Right there. Let me just highlight that. Bought some shirts for $13 a piece. Does that tell you how many shirts we bought exactly? Yes or no?
No.
Nope, not quite, right? Not yet. Not yet. And that's fine. But they did give us some pretty important information about the shirts, right?
Yes.
Yes.
Absolutely did. Absolutely did. We know that it's $13 per shirt. And so let me go ahead and do ourselves a favor here. The number of shirts, I'm just going to call it, I usually don't use X because I want you to use a letter that has to do with the problem. But because the letter would be S for shirts, that can get confusing, right? S, is it 5? Is it S? I'm pretty sure some of us have been there before where we write an S and we think it's a 5. So let me go ahead and just put X. And again, that's the number of shirts. So if we have $13 per shirt, do we multiply every shirt that we have by 13, or do we divide every shirt that we have by 13? Which one is it going to be, guys? No, I'm saying multiply. If we knew the number of shirts. If multiply. We're multiplying. Because if we have one shirt, that's $13, right? If we had 2 shirts, that's 13 times 2, $26. If we had 3 shirts, 13 times 3, and so forth, right? We get the idea, right? Everybody, yes or no? Did we get the basic idea there in terms of, hey, the number of shirts that we have, multiply by 13 to get the price? All right, cool. So let me go ahead. Again, $13 per shirt. Everybody, do you agree that that means 13x? Again, this will give you the cost of everything. Just want to make sure that we understand that so far. And now, what I'm going to do next is continue looking for any information that I can use. Because notice how they give you that every shirt is $13. But how are we going to use that, right? So let me continue going here. Later, she spent $35 on a pair of jeans. Let me highlight that right there. $35 on a pair of jeans. Okay, so I can just say, hey, $35. right? I'm just going to leave that there, $35 for jeans. And then we see right here, $10 on lunch. All right, cool. $10 on lunch. $10 on lunch. And so that amounts to just $10, right? It just says that, Kelly had one lunch, and so that was it. And then it says at the end here, if she spent $110 at the mall, spent $110 total, right? $110 spent. And so let me ask you guys real quick. Let me ask everybody here. Notice how we have different pieces of information, right? Notice how we have, okay, $13 a shirt. We got $35 for a pair of jeans, $10 on lunch. That 110 right there. Notice how it says if she spent $110 at the mall, notice that she went shopping at the mall. So everybody, is the $110 what all of this adds up to? Is the $110 what all of this would add up to? The shirts, the jeans, and the lunch. When we put all that together, $110, is that going to be it?
Yeah.
It is. It is. Because again, we take the shirts, we take the jeans, we take the lunch, bring it together. That's going to be the amount that you spend at the mall, which is given to us as $110. And so here's the thing. Listen to what we just said here. We just said, if we add up everything we purchased, we'll get $110, correct?
Yes.
If we add up everything we spent, we'll get $110. So right here, watch this game. If I go ahead and just say 13x, so my shirts, if I add on the $35 for the jeans, if I add on the $10 for lunch, that is supposed to equal, let me go ahead and lower this a little bit. That's supposed to equal $110. Does anybody who agrees or disagrees with this right there? This equation?
I agree.
Oh, you agree, Justin? Sounds good.
Agree.
Sounds good. Angelina, Dilson, okay.
Agree.
I agree.
Right on. Right on, right on, right on. And shout out. We have 104 people in the class today. Right on. Let's go. All right. So with that, that's how we set up equations here. Notice how we didn't explicitly see the word is, equals, will be, but we do know that Kelly went shopping at the mall. This is everything she did at the mall. And this is the grand total after all of that. That was implied, right? That was implied. And you got to be ready to look at situations like that intuitively, like with common sense, and be like, all right, cool. We bought all this stuff. That's going to total or equal 110. There it is right there. And what do you think we're going to do now, gang? After we set up the equation, what are we going to do?
Subtract.
No, add 35 and 10.
We have to work backwards.
Kind like terms.
I love it. I love it. So let me go ahead and mute everybody real quick because we're going to take over now. And we're going to do it. So with that, great input, everybody. Let's get it done. So there's a few different ways we can solve equations. First, right here, when we're taking a look here, before we go crazy, remember that the first step when you're solving equations is first check to see if you can simplify something, adding terms or anything. Right here, I see 35 and 10 that I can add together. Everybody, 35 plus 10, what's that going to give me? Correcto mundo. That's right, 45. Good stuff. Right there, 45 equals 110. So now that we've taken care of that first step, in combining these like terms, now we want to take a look at this and say, okay, we got to work backwards. Because remember, everybody, solving equations is the art of working backwards. I've taught you guys this all day, every day. Shout out to my new folks. You're going to learn that today. So with that said, here's how we work backwards. Here's an easy way. We know that the goal right now is to solve for x. Let me use a different color here. Let me use purple. Right now, I'm looking for x. I got a 13 attached to the x. And then there's the 45. So to work backwards, it's like kind of trying to breaking down this box. I'm trying to break that box to get to x. If I break this box, I got the 45 to deal with. Everybody, what's the opposite of adding 45 here? What are we going to do? That's right. We're going to subtract 45. So far, Roxanne is the only person to say it correctly. Subtract 45 on both sides. Simone, shout out to you as well. Thank you. Remember to be specific. So many times we forget that we have to do it to both sides. So here we go. I'm going to subtract 45 from both sides. Now you can go ahead, use a little bit of mental math. You can go ahead and do it with long subtraction style with your pencil on paper. Either way, what you're going to get here is 65. It's going to be 65. After you subtract 45 from 110, you get 65. One way that you could do it easy, honestly, you can subtract 40 first and then subtract the extra 5. Make your life easy. If you want to do it in your head, you're doing 110, take away the 40, that puts me at 70. 70, let's take away that 5, 65. Not too bad, right? Not too bad. I want to encourage you to do mental math when you can. I'm trying to encourage you for that. Because the thing is, you only get a minute. So with that said, now we have 13x. All right, quick question, everybody. What operation is happening right now between the 13 and the x? Even though we don't see the operation, what operation is it? What operation is happening right now? Not what we're going to do, guys. Not what we're going to do. What is happening right now between the 13 and the x? Yeah, multiplication is that. I love how you're getting ahead of the game right now. I see y'all people right now. Y'all are like, I want to solve it. I want to solve it. I see y'all. I love it. But we got to take a look at this and be like, all right, look, right now it's 13 times x. What's the opposite? Divide 13. That's how you want to think about it. What's the opposite operation? And so with that, we'll divide both sides by 13. And what's that gonna give us? It's gonna be boom, cancels out right there. Let me actually make that look even a little better. Cancels out right there, gives you x equals, and then you have to understand what 65 divided by 13 is. And so again, you can use long division, you can try to use mental math, but at the end of the day, what you will receive is 5. 5 what, everybody? 5 what? 5 shirts, exactly. Remember to bring the context back. Make sure to bring the context back. And so there it is, 5 shirts. But let me go ahead and recap this for us, everybody. I got to recap this for us because there were 3 main steps for this problem. 1, it was understanding the question. Then it was understanding the keywords for your setup. Notice how this setup right here, if this is wrong, the whole thing is wrong, right? And so that's number 2. And then number 3, it's actually solving the equation. And so with that said, I want you guys to shout it out in the chat box, please, in the chat box, not with the mic, in the chat box. Which phase right now is hardest for you? Is it identifying the question? Is it setting the problem up? Or is it actually solving the equation? So which one of these is the hardest part for you? 1, identifying the question. 2, setting up the actual problem. Or 3, solving the actual problem with the math. All right, so I see here, setup, identifying, setting it up, identifying, solving. But then I see again, setting up. And I'm not going to repeat myself anymore. You guys get the point. The majority of us really feel like it's setting up the problem. And so with that said, that's why today, that's the focus. Being able to look at the problem, not blank out, and actually set up an appropriate equation to solve it with. That's what we're doing here. So thanks for sharing, guys. I appreciate that. I love the participation today, actually. I love it. So with that, here's what we're going to do next. What we're going to do here is we're going to take a look at these problems coming up next. And what we're going to do is we're going to work to set up the actual equation. So that's what's going to happen in this next bit here. I'm going to give you 2 minutes to try to set it up and then another 1 minute to actually solve it. Okay. That's what's going to happen here. And so before we do that, let me see here. Yeah, no, we're not going to do that one. I was debating on doing that one. No, I want to keep it easy for you guys. That way tomorrow we'll transition into those higher order problems. And so that's what we're going to do here, guys. Using your notes, you're going to have 2 minutes to set up the equation. Don't worry about rushing to solve it. Just worry about getting the information right and setting it up. That's all you got to worry about, okay? We're going to have 2 minutes. Once you're ready, once you have the appropriate setup that you think is good, simply type ready in the chat box and leave it at that. Don't share your answer. We want people to have a chance to solve it. Here we go. 3, 2, 1. Let's try it out here. 2 minutes. Let me go ahead and mute y'all real quick. And let's go. All righty, looking at our final 15 seconds here, final 15 seconds. So get ready to lock in an answer. 3, 2, 1. Let's try it out. Even if you got stuck, take a guess. On the ASVAB, you're allowed to take a guess. And if you get lucky, great. But remember, guys, with all these answers that we're putting in right now, it doesn't matter. It doesn't matter if you get the question right or get it wrong. Everybody, what do I always say? What is the most important thing? It's not about getting it right or wrong. It's about what? Simone, understanding why. Kaylee, the why, right? Ania, trying and understanding the why. Understanding the why. You can get a problem right. You can get a problem wrong. It's part of practice, right? It's going to happen. But if you're not questioning and asking why, then your confidence is going to stay exactly where it was. And so you can get every single problem wrong in a group tutoring session, but you can be so much more confident after the fact if you understand why you got them wrong. So I want you guys to really get into that mode here. So let's start off here. So everybody, what's the question? What is the goal of the problem? What are we trying to do here? What are we trying to do? Find the equation, find the setup, exactly. So Tamika, not exactly. We're not trying to find the number of weeks yet. We're trying to set up an equation that will get us the number of weeks, right? That's what we're trying to do. We're trying to set up an equation so that we can get the number of weeks. But there it is right here. Which of the following equations, right here, let me go ahead and make this bigger. Which of the following equations used to find the number of weeks until they have the same amount of money? So we want to set up an equation so we can find out when Jeremy and Katie are going to have the same amount of money in their bank accounts. All right, cool. So with that said, we know the goal. Write an equation. Write the equation. Now, this is not going to be easy, guys. It's not going to be easy, but stick with me because we're going to look at these key words that are going to show us what we're doing here. Watch this. Watch this. So we got Jeremy has 120 in his savings account. Katie has 180 in her account. Each week, Jeremy adds this much money into his account. Katie adds that much money into hers. Notice how I don't really care about the numbers, and you shouldn't either. The numbers don't matter until you know what they mean. I'm gonna say that one more time. Write this down if you've never heard that before. It is not about what the numbers are. It's about what they mean. It could be a decimal, could be a fraction. It doesn't matter. It's about what the number means. That way you can set it up the right way. Then you'll deal with your anxiety about fractions and decimals and all that jazz later, okay? So here we go. If we want to find out how many weeks it'll take until they have the same amount of money, is it fair, everybody? Is it fair if I say that we're trying to write Jeremy equals Katie? Is it fair to say that, in a sense, like that's what we're trying to do? We're trying to set up Jeremy equals Katie and then solve that equation. Is that fair?
Yeah. Mm-hmm.
Right on, Keto. What's up, boss?
What up, brother?
Yeah, right. That's fair to say. And again, all we're trying to do is start in English. Like, I know that there's so much to do, but let's just start in English. Plain and simple. We're just trying to make Jeremy equal Katie when it comes to money. When it comes to money. All right, when it comes to money. So with that, here's what I'm going to suggest, everybody. What I'm going to suggest is let's go ahead and write Jeremy's money on the left, and let's go ahead and write Katie's money on the right. And so we're going to have to represent that. And so what I'm going to do here is in green, I'm only going to highlight Jeremy stuff. And in red, I'm going to highlight Katie stuff. Follow along with me, everybody. Follow along. Jeremy has 120 in his savings account. And then we see that each week, Jeremy adds $14 into his account. So let's take a look at this. Everybody, is $120 for Jeremy, is that a starting amount or is that something that is going to be added on every week?
Starting.
Yeah, that's a starting.
Yeah, that's a starting amount. Yeah, that's a starting amount. And for those of us with experience in setting up and solving equations before, when you have a starting amount, is that number typically by itself or do you put the variable with that number? Typically, what do you usually see?
By itself.
By itself.
Exactly. Typically, you would see that number by itself. If it's a starting amount or the initial value, right? Or the starting point, it's typically just by itself. Typically, it's just by itself. And so I'm going to go ahead and just write it out right there. So we have $120. And then we also see over here that each week, everybody, the word each, that's a key word, isn't it?
Yep.
Ain't that a key word? What operation does that usually tell us that we might be looking at?
Yep. Division. Multiply, right?
Multiplication.
Typically multiplication. And so it depends on the context. If I say each week, $14, that's multiplication. If you say, oh, each student is supposed to receive 6 balloons,
Divide.
and there's balloons, that's dividing. And so you're going to have to continue practicing to learn that difference, right? Because each can go both ways depending on the situation. But if you're stuck, assume multiplication, you're fine. If you're stuck, assume multiplication. Each right here, multiply. Keyword, multiply. You see each week. Everybody, what letter represents weeks again?
W.
Yeah, W. So every W, that's $14. Is that correct?
Yeah.
Yeah. So we're going to add on $14 every week right there. 14W. What does that mean? Everybody, think about this intuitively. If I'm supposed to add $14 every week, everybody, how much money is that in 1 week? If I'm supposed to add $14 every week, the first week, how much are we adding? 14, right?
14.
All right. Let's continue playing this game. What about week 2? How much money are you going to add total in week 2?
28.
28. Okay. So what do? We times it by the weeks, right? 14 times 1 week is 14. 14 times 2 weeks, 28. 14 times 3 weeks, you get 42. Then you get 56. Then you'll get 70. And you'll keep going and going and going and going. But all I was trying to demonstrate was that you're multiplying W with that rate. If it's 14 per week, it's 14 times the weeks. 14 times W. Yes or no, everybody? Does that make sense before we move on? I really got to make sure that makes sense because that's the biggest.
Yeah, it makes sense.
Sure.
That right there is the biggest piece. That right there. 14W, 14 per week. Right there. All right, great. Cool. And be honest, because if it's a flat, no, that's fine. Because I know I'm not perfect. I want to make sure that you at least feel comfortable knowing what direction we're taking. But there we are. We have the 120 plus $14 per week. That's why it's multiplied. What you started off with, and you're adding on 14 every week right there. And so some way, somehow, some way, somehow, this is supposed to equal Katie. Now let's go ahead and talk about Katie real quick. So with Katie, let me go ahead and use that red right here. Katie has 180 in her account. So everybody, is that the starting amount or is that what we're going to be multiplying by?
Multiply.
Starting.
Multiply.
Multiply.
Multiply, right?
Nah, that's a starting amount. You
Yeah,
see
that's
here
a starting
that
now.
It says
Katie has
A.
180
It
in
says
her
A.
account.
Wow.
Notice that
Okay.
nothing is happening to the 180 right now, right? It's just
Right.
saying that she has 180 in her account. It's not saying that 180 is being multiplied. It's not saying anything else about it. It's just saying 180 is in there. And so that's a starting amount. So this is what we start with. That's what we start with. So we just start off with 180. And then notice over here, each week, Katie adds $10 into her account. So what does that mean? Is that the same thing as saying 10 per week?
Yes.
Yes, sir.
Yes.
Yeah.
And so
Yes.
what do we do with the $10 with the number of weeks? What are we doing with those two things?
You're
Plus
adding,
$10.
adding 10.
Bringing them together, right? That's why I said plus.
Yeah, but
right?
how are we bringing them together? What operation?
Multiply.
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 Multiply. Because guys, use that common sense here. If I think about week 1, that's $10. If I think about week 2, that's another 10, so $20. Oh, 10 times 2, okay. After 3 weeks, 10,
30.
10, 10, 10 times 3.
30.
Let's think about 12 weeks. That's 10, 12 times. 12 what? 12 times. 10 times 12. And so what we would have here, we are adding on $10 for every week. And that's it right there. So I want to go through it again, everybody. Right here, we start off with that 120, and we're adding $14 for every week. And that's supposed to equal Katie's money. And Katie's money is, she starts with $180 and she adds on 10 every week. And so just take a look here. This is the equation. But the reason that this is the equation that's going to work is because you don't know what W is. You don't know the number of weeks. You just know that at this week, Jeremy and Katie will have the same amount of money. And so that's the purpose of solving the equation, to find out what that W is. But are you seeing, or are you starting to see how the setup is actually done here?
Yes.
Yeah.
Yes.
Like the detail that's needed, it's insane. We have to really get in there and understand these little pieces and how they interact. But with practice, I promise you, with practice, we will make that progress and get there. It's going to be tough, but remember, just because it takes a long time does not mean it's impossible. And so, everybody, so the answer here is going to be what?
A.
It's going to be A.
A.
And so with that, why is it A? We have 120, but 120 appears there. And then we have 14, but 14 appears here. What? How does that make sense?
That's the same thing.
Each person.
Same thing. Exactly.
Same
Everybody,
thing.
1 plus 2 is the same as 2 plus 1, right? 1
Right.
plus 2 is the same as 2 plus 1. And so we're perfectly allowed to say 14W plus 120 equals, put that in the front, 10W plus 180. You're perfectly allowed to. And so with that, that's why A is the answer. Yeah, that's right, Angelina. We're going to pass the ASVAB. We all are. That's right. Let's get it going. And so on a scale of 1 to 10, how much sense does that make in terms of setting up the problem? On a scale of 1 to 10, how much sense did that make? Because we're about to go solve it now.
10.
10, 6, 8.5, 10.
Wow.
I say 8. 8.
Let's say 8. I still need more time to practice.
Oh,
Yeah,
for
that's
sure, right?
it.
We
It's more
can't, we
time.
can't achieve perfection off of one problem, right? And that's why practice is important. Absolutely right about that. All right, cool. Thanks for the honest input, everybody. Thanks for the honest input. So allow me to mute you guys real quick. Now what I'm going to do is I'm going to allow you a minute and a half real quick. I'm going to allow you a minute and a half to solve the equation that we just set up to figure out how many weeks it'll take until they have the same amount of money saved up. So again, your goal right now is to solve that equation right there. Let me go ahead and restart my watch here. Go ahead. So your goal now is to solve the equation. I see you, Simone. Still got 20 seconds left. And again, do your best. Go as far as you can. Do your best. We're covering a lot more tomorrow, so you're good. Final 10 seconds. 3, 2, 1. Share those answers. Let's go. What do we have, gang? What do we have? What do we have? What do we have? Let's check it out. All righty. So let's go ahead and go through it here. Let's go through it. Let's go ahead and have as much fun as we can. And let's see what the answer is. So first and foremost, everybody on the individual sides, let me go ahead and make it smaller here. All right. On the individual sides, is there anything we can simplify on this side or anything that we can simplify on this side? Nope, 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 nope. That's right. There's nothing that we can simplify, right? It's not like we have another regular number or another like number with a W on it on this side or on this side. So like it's pretty unique. It's already there. It's simplified. And so now we're just going to get straight to solving the actual equation. And so everybody, quick question before I continue here. Is it legal? Is it mathematically appropriate? Is it okay if I start off by subtracting 14W instead of subtracting 10W? Is it okay if I did that? Right. It is okay. Yes, it is. Is it wise to do that though? Is it wise? Nah, it's not, right? It's not really the smartest thing to do because it's going to give you a negative and then you got to deal with negatives. And we all know what happens when, especially if we're beginning, dealing with negatives means no, right? So we don't want that. We don't want that. We want to go ahead and keep it positive here if we have anything to do with it, if we have anything to say. And so remember, whatever you do to one side, you do to the other. And if solving equations is not your strong suit right now, don't worry. We've got plenty of videos and plenty of practice with this coming up today and tomorrow. So we're good. But the first step here will be to subtract 10W from both sides. And with that, on the right side, it cancels out. Everybody, 14W minus 10W. What is that supposed to give us? 4 what? 4W. That's right. 4W. And now we still have the plus 120 equals, and we have the 180. Remember, this cancels out. And so my next move will be what, everybody? Be specific here. Be very, very, very specific in that chat box. Subtract 120 to both sides. Subtract 120 from both sides, on both sides, on both sides, on both sides. There we go. Thank you for being specific. There we go. That's the kind of specificity that will get you that higher score every time. If you are disciplined enough to give the exact thing that you're supposed to be doing, boom. Let me use the highlighter here, actually. That's going to cancel out. And so we're going to be left with that 4W. 180 minus 120 gives me a 60. And the last thing we need to do is, again, the opposite to both sides. And so, exactly, we're going to do the same thing to both sides. We see that we are currently multiplying W and 4. So what I'll do is divide the 4 on both sides. That's right, on both sides. And so with that, boom, that's going to cancel the 4 out on the left, leaving us with W equals what? Correct. It's going to give us 15. So let me go ahead and shout out mental math real quick. Let me just show you how mental math can really, really save you from a headache if you don't want to do this. If you don't want to do, hey, we don't want that, right? We don't want that. What you can do is, everybody, if you're dividing by 4, is dividing by 4 the same thing as dividing by 2 and then dividing by 2 again? Yeah. Dividing by 4 is the same thing as dividing by 2, then dividing by 2 again, because 2 times 2 is 4. So everybody, 60 divided by 2 is 30. 30 divided by 2, 15. Boom, done. You can make your life really easy there. But everybody, quick question, 15 what? Weeks. That's right. 15 weeks, 15 weeks, 15 weeks, 15 weeks. And so that means 15 weeks until Jeremy and Katie have the same amount of money in their respective bank accounts. Right there. And there we have it. And there we have it. And so that was the actual solving portion of it. Again, that's not today's main focus. Today's main focus is setting it up. That's what today's main focus is. And so I know it's 6:53 already, but we got to make sure that we understand the setup more. So are you guys down to do one more problem here? One more, one more, one more. There we go. I pride myself in making people want to do math. That's my job here. So with that, here we go. I know it's already 5:50. These classes are fun. They're short, but remember, Tuesday and Wednesday, they're 2 hours long, all the practice in the world. And so here we go. Hey, Frida, that's the point of practicing, right? Here we go. 3, 2, 1. Let's try the setup again. Oh, did I take that away already? Oh, okay. Let me see. Yeah, no, this one's going to be out of the ballpark right now. So let's go ahead and set this one up, okay? We're going to be setting this one up. So again, I'm going to give you the 2 minutes here. I'm going to give you the 2 minutes starting soon. But the first step here, set up the equation. Not solving it. Again, don't worry about solving it. I want to see a setup. So I'm going to give you 2 minutes right now. Go. And what we're going to work on is simply setting up the equation. Go. Bonus if you can get the correct answer. Again, bonus for that. But today, right now, it's only about the setup. Go. And in about 30 seconds, I'll drop some hints for you. All right, there's the big hint there. Still got 20 seconds here. Angelina, all that means is that you took an intuitive approach and that still works just fine. But we do want to know how to solve, to set up the equations when it comes to those more difficult problems. But you use an intuitive approach to solve this, which is a great thing. That's probably what a lot of people would do. But I'm going to show you how to set up the equation to see how the math actually lines up. Gotcha? And so we're looking at our final 5, 4, 3, 2, and 1. So go ahead. If you have a setup, if you have the equation set up, go ahead and write out the equation if you can. If you already have an answer, go ahead and just pick the answer that you got. Now, what I want to know after you put in your answer, write your setup, I want to know, do you feel like in a problem like this, it's super easy for you to solve this without an equation? That's my question there. Do you feel like it's easy for you to do this without an equation at all? I see a few yeses. I see some no's. So it's more yeses than no's right now, clearly here. Hey, it's all good. Hey, confusion is okay. Because when you're asking yourself, okay, I'm confused. Ania, I'm going to tell you right now, this is the best way to learn. Whenever you're confused, ask yourself, okay, what is it that I know? Like, what can I get to? Do I know what the question is? And then ask yourself, okay, what's the confusing part? What am I confused on? Oh, setting up the equation. And when you ask yourself that, you point out what you can do moving forward. So Ania, tell me if this makes sense. If you're saying, hey, man, look, the setup is confusing me. If I were to be like, okay, what did Mr. Duran teach me? Keywords to get those operations. Okay, what are the key words in the question? Do you see how you turned frustration into curiosity there? Cool. That's what that's about there. Turn that frustration into curiosity. That way you can move forward bit by bit. And so that question was, okay, this setup is kicking my butt. What is it that I can do to set this up properly? Keywords. What are those keywords going to be, right? And so with that said, let's go ahead and take a look here. First off, the question is, let me use pink here. We want to know how many bags of peanuts did she sell? Right there. So what we're looking for here is bags of peanuts. Everybody, what letter do we want to use for bags of peanuts? Go ahead. What letter should I use? Yep, let's keep it simple. P. So equals P right there. So bags of peanuts equals P. Okay, cool. Now, let me go ahead and look back at the problem and only grab the information about the bags of peanuts. So Alice sold candy for a school fundraiser. Okay, great. Cool. Alice, cool story. Chocolate bars sold for, I don't care about chocolate bars. Bags of chocolate covered peanuts. There we go. Peanuts sold for $2 a piece. Okay, so I'm gonna go and highlight that right there. And I'm gonna attach that to this here. Each bag is $2. So everybody, what's the key word there? What's that key word? What's that key word? What's that key word? What was that key word? Each. Exactly. Each bag is $2. So that means one bag is $2, two bags is $4, three bags, 6, 8, right? We're multiplying. That's right. That's right. That's right. I love it. We are multiplying. And so you can say that for the cost for peanuts, you could say 2 times P, right? Is that fair to say? 2 times P, right? Yeah, that's pretty fair. 2 times P. Every bag times 2. Every bag times 2. Now, let me go ahead and go in here and let me start talking about all of the other information, because we want to know the peanuts here. We don't have enough information with just peanuts, but we do know that chocolate bars sold for $1 a piece. And what does that mean? $1 per chocolate bar, right? That's 1 times all of the chocolate bars. And so everybody, watch this. Watch how I'm doing this. This is how I really want you to start thinking about this in English with common sense here, and then trying to poke the math in. So if I do, everybody, does this make sense? If I say the cost of peanuts plus the cost of chocolate, the chocolate bar, if I do that plus that, and then I add on the cost for lollipops, is it true that all of that together will equal the total cost? Is that true? If I take the cost of the peanuts, add the cost of the chocolate bars, add the cost of the lollipops, all together, is that going to equal the total cost of buying all that? Yeah, it will, right? It will. So that's what I'm saying. Like, talk about it in English first. Talk about it in English, because that's what's going to drive your equation. That's what's going to drive the equation. So write that down if you didn't write that down first. Please do. Again, set it up in English before you set up an equation. Set it up in English before you set it up with math. The more you practice this, I'm telling you, the more you practice this, the easier it gets. I understand completely that it's probably not as easy as it should be in your first try, but as you continue moving forward, it will get easier. I promise. I promise. Okay. Set it up in English before you set it up in math. And I'm not saying, that it's only in English. Like, if it makes sense in your native language, please try it out. It's just talk about it in English, because watch what we're going to do now. We have the cost of peanuts. That's 2p. What do we know about the cost of chocolate bars? We know it's $1 times every chocolate bar. Everybody, how many chocolate bars did we sell? Right there, right? 9. So 9 chocolate bars. 9 chocolate bars right there, right here, right? And so we're going to do 1 times 9. And then in blue, let's go ahead and talk about the lollipops here. Okay, lollipops sold for 50 cents each. So it means 50 cents times the number of lollipops. Everybody, how many lollipops? That's right. Boom, 10 lollipops right there. We sold 10 of them. And then that's going to be the total cost. Everybody, were we given the total cost? Was that given to us? Yeah, I see y'all giving it right there. Yeah, 40 right here. In black right here, 40. That's the total cost. In all, total cost. Total cost right there, $40. Everybody, so far in English, does that make sense? The cost of peanuts, which is 2p. Again, 2 times the number of peanuts. The cost of chocolate bars, 1 times 9, because it's $1 for every chocolate bar. You got 9 of them. The cost of the lollipops, they 50 cents each, multiplied by 10 lollipops. And that's supposed to give you 40 when you add it all up. Yes or no, everybody? Does that make sense before we proceed? Because if that makes sense to you, then you are on your way. That's progress right there. If you can start off with making it make sense in English, then translating it into math, then solving it, you're in a really good spot. They're in a really good spot. So let's go ahead and crack this thing. Let's finish this off. So we have 2p. Everybody, 1 times 9, quick. Yup, 9. Plus, everybody, multiplying by 0.5 is the same thing as doing what? Dividing by what, John? Exactly, dividing by 2. Divided by 2. Because everybody, is it true that 0.5 is the same thing as saying half? Right? 0.5, that's 50 cents or half, $1, right? Yeah, exactly. 0.5 is the same thing as half. And so, everybody, what is half of 10? Exactly, 5, exactly. Equals 40. Let's finish this off, man. Let's finish this off and let's have a good time. So, we're going to combine like terms real quick. 9 plus 5, that's going to give us 14. So we got 2p plus 14 equals 40. Everybody, what do we do to both sides real quick? Let's go. Des, what's up, boss? Yep, subtract 14 from what? From both sides. That's right. Angela, that's right. Carlina, what's up, girl? Yeah, we're going to subtract 14 from both sides there. Not 40, excuse me. Booyah. We're going to go and cancel that out right there. And then we got 2p equals what? What is 40 minus 14? What is that going to be, everybody? 26, correct. 26. And then from there, what do we do to both sides? Let me just rewrite it over here. What do we do to both sides? Correct. Divide by 2 on both sides. Because that's going to cancel this on the left, giving you p equals what? 13. 13 what? 13 what? Bags of what? Bags of what? Bags of peanuts. That's right. Bags of peanuts. Right there. Right there. And so I know that solving the actual equation was probably a lot, right? But the fact of the matter is we want to focus on the setup. This right here is honestly the most important thing. This is bread and butter right here. This is bread and butter. If you can talk about it in plain old English in the way that you understand it before getting into the math, I'm telling you guys, like that's success right there. That is what will spell success. Everybody, yes or no, on a scale of 1 to 10, how much sense does that make? Setting it up first in English in the way that you understand it before getting into the complicated math. It's kind of like a middleman kind of thing. That's really what it is, guys. That's too important because none of this will make sense or even get you the right answer unless this makes sense in your head. Like your confidence is based off of how well you understand it. And if you can't explain it with your own words, then that's where we have trouble. That's where it comes from. And so I'm just showing you where that confidence comes from, guys. Exactly. So you know before calculating. Exactly, Victor. And that's why the answer is A, 13 here. And so everybody, do yourself a favor. Take a screenshot of this problem real quick. Let me go ahead and move this over here. Take a screenshot of this problem before I move on. Take a screenshot of it. Right on, PR. Right on. All right, cool. So hopefully that was enough time to let you screenshot it because as a reminder, Tomorrow, we have a 2-hour session, and we're going to do the same exact topic. We're doing new problems. We're going over this for 2 hours, more problems, more in-depth, and I'm going to make sure that by the end of it, you understand how to set up equations. You understand all these keywords, and by the end of it, I'm telling you, everybody here is going to be like, yeah, we're good. We're going after it, and we can be calm, cool, and collected when we see a new problem. Like that's. Hey, Anderson here, your ASVAB coach. If you like what you saw in this video, make sure to give us a thumbs up, comment, and subscribe. That way we can keep putting out great content for you. Also, if you want to join my group tutoring classes or raise your score with other courses like my bootcamp courses for math and word knowledge, hey, do your thing. The links are in this video, so that way you can raise your score and get the military job you deserve. And so with that said, again, I'm Anderson, your ASVAB coach. Let me know if you have any questions. I'll see you in the next video.